I'm from up in Cape Cod in Massachusetts, an area. We've got 192 miles of coastline, a lot of variety, a lot of cold water stuck out right into the Atlantic, so you can imagine the temperature extremes. And if you look at that little hook that's Cape Cod, the inside of that hook is Cape Cod Bay. And there are areas within that when at low tide, the tide recedes for up to a mile. So your oysters, if they're out in Cape Cod Bay, can be exposed all the way out a mile into low tide and for a couple hours at a time. So the oysters there are very well adapted, as everywhere, but they're a surviving species that a lot of temperature extremes and moderations that they're adapted to. So anyway, up in Massachusetts, the aquaculture industry has really been taking off for the past 20-odd years or so. So if you look at our graph up there from 2004 to 2017, the value of oyster and clam aquaculture production was $3.7 million in 2004, and as of 2017, it approached over 28 million. And if you figure in an economic multiplier, it's over $50 million brought into the state, which is something that finally legislators and the other folks in power and with funding and assistance are really paying attention to. We have in 2017 over 390 licensed shellfish growers, and these are growers that have farms, and they're doing this on over 1,300 acres. It doesn't sound like a lot of area. It's pretty intensive on the grounds that they work on, and the grants themselves are generally an acre and a half, 2 acres, usually just a couple acres in size. A picture of the industry. It doesn't look much different wherever you go. The gear might be a little bit different, as well as the challenges. You see the fellow under the umbrella, he's from up in Wellfleet on Cape Cod. His biggest challenge, not challenge, but danger, comes from sharks that are starting to come into the bay. I imagine some of you have to deal with alligators, but up where we are is sharks, and he's had to modify the way he does his business. He's bought a bigger boat. No, I'm serious. He bought a bigger boat and requires everybody working on the farm when the tide starts to come in and it's about knee deep that they no longer work in the water and to get out. And it's husbands and wives working. It's men, women, multi-generational. You'll have grandfathers with grandchildren, and just everybody definitely becomes a family business. And myself, I'm working for Woods Hole Sea Grant, Cape Cod Cooperative Extension, and I also wear a third prong to my hat. I help staff CMAC, which is our Southeastern Massachusetts Aquaculture Center. As the Sea Grant and Cooperative Extension Marine Program, we're really a quite small program. We only have 3 extension agents. And the tool that I'm going to tell you about, the Research Farm Network, was designed to further applied research and extension. CMAC has provided a lot of the funding for our Research Farm Network, and it's one of 3 aquaculture centers in the state. And we have received funding through that from the State Department of Agricultural Resources. And it's helped to guide the state's what we call the blue economy. And through CMAC, we don't draw any salary from that. All the funds that we receive go straight into projects such as water quality monitoring. We have one of the longest running nonstop water quality monitoring data sets in the state, probably for the past over 12 years. And we also do disease monitoring and as well as other projects. So going back, imagine if you will, Mr. Walton, Dr. Walton, back in 2005 was when this had its inception, the Research Farm Network. What we were finding, a lot of the issues and challenges that were coming up in the state, there was a commonality amongst them, and the growers had questions, and we had no physical address to really carry out research, but we did have colleagues in the field, the industry that we were working with. And so Bill had the idea of using models that were already in place, such as the molluscan broodstock program. And then there was a terrestrial model in Massachusetts for the cranberry growers. The cranberry growers had a state research station, an experiment station, where they could explore pest management, looking at how to grow their crops better, looking at new species or plant cultivars. Well, this is something that could be applied also to the shellfish industry. And so the goals were to help improve production throughout our region, throughout the southeastern Massachusetts region through applied research, trying to address those issues that were relevant to our shellfish farmers, ultimately to help them improve their profitability of their farms. So by establishing this network of research farms, where instead of one location where all the research was carried out, we found that it was more beneficial to work across the region and collaborate with the shellfish farmers, and in water bodies where there was a good concentration of aquaculture taking place. And this had an added benefit of really increasing communication amongst all of the growers, as well as we were then boots on the ground, and we would be able to meet with the growers and hear other issues that were coming up. And the setting this up, we did it so any experimentation that took place would be identical in methodology wherever we went, so that we could compare, from site to site as well as throughout the region. And this is sort of morphed a little bit over the years, but at that point in time, we chose the farmers that we would work with by putting out a call for applications, so to speak. And we would choose 10 to 12 quote-unquote foremen to run the experiment for us. And the research questions wasn't just ideas that Bill and I came up with. We worked heavily with our CMAC. We have a board members, like about a 13-member board of directors, as well as industry. And they would all come together and help design our experiments and the protocols for those experiments. And then we would collect the data and analyze the data and then share that, disseminate the results. And generally, most of the research projects carried out over 1 to 2 years. Typically, if you have animals that are growing, you're going to need more than 1 year out in the field. We provide all the materials, and if they are growing oysters or an alternative species, we provided the seed as well. That way, we would have the same cohort of seed from the same hatchery or hatcheries and be able to standardize our experiments. The participants, the growers, would receive a small stipend for their time, and they would be allowed to keep the extra seed and gear. And so there was an application process, and we tried to spread this out throughout the southeastern region. We would have an application form so that we would have a better idea if the applicant, they had site accessibility, they would a site that we would be able to access, if they practiced best management practices. And if more than one grower qualified, we would then go through a lottery process. And they would also, the grower collaborator would agree to follow the experiment protocols. So, some of the early experiments, and some of these continued to this day, but some of the things we looked at: effective oyster density and rack level on growth, the use of periwinkles as a biological control, quahog density on growth, the effects of brine dipping on shellfish, and looking at floating versus bottom gear. I just drank somebody else's water. I don't know whose that was. Okay. So, looking at I know you all hate graphs, but these are pretty simplistic. The effects of oyster density on growth. So you can see those are I don't know, a little over half a dozen sites, but they're all variable in the growth effects determined on density. So we went from densities of 50 per bag on up to 250 amongst those sites, and then we were able to compare the results, share those locally and then more broadly to help the industry. Tests of rack level. This is just one site that we had in one of the towns. And so those oyster cages, you'll have a top, middle, and a bottom rack. And this particular site, it showed that the overall shell length of the oyster was significantly less in the top rack as opposed to the middle and bottom levels. So that was also useful. And we found that to be true at many of the sites, but not all of the sites. Again, all of this is just points to the importance of the site specificity and how everything can be so variable. And that the effects of periwinkles. Periwinkles, I don't know if you have them down here, but they're a grazing snail that will eat the biofouling, the mild algal biofouling that might be on the outside of an oyster. So we added those in different densities to bags to see if they would help keep the growers' oysters clean. And we also we dosed the oyster bags at different densities with these grazing snails. And as it turned out, at higher densities, or even the inclusion of periwinkles in a bag, although the oysters came out shiny clean, they looked like they'd been power washed, they also had an effect on the oyster growth. And the shell length was sacrificed by having periwinkles in the bags, perhaps by having so many snails climbing over them that it might have inhibited some of the feeding of the oysters, or competition, I don't know. But that effect also varied by farm. So across all those different farms that we worked with, it was not consistent, those effects. Diploid, triploid oyster growth. The use of triploids has become so common today. But back when Bill Walton was, when I was working with Bill, triploids were not used in our region. And this actually caused quite a stir. Nobody knew what they were. The Franken oysters, they were GMOs, they were called every name in the book, incorrectly so. So Bill had an idea, and our purchase order that went into the county commissioners was for, I don't know, 500,000 tetraploid sperm. Remember that, Bill? Yeah. And there was a lot of raised eyebrows. Bill had to explain what it was we were buying, actually. So this particular experiment, we collaborated with the growers, and we set them up with 2 cages with triploids and diploids, the same experimental design and identical treatments. And here again, you'll see the site variation. That top dish from one of the sites shows the difference on the left between the triploids and the diploids. And underneath that was another site, different location. You can see how the triploids and diploids grew quite differently between the 2 sites, and these were all from the top level. So in those oyster cages that I talked about, that top level, that's a comparison of how they grew. And as it ended up, we found that during that study period, that the survival was significantly greater in the triploids than it was in the diploids. And they had the potential to exhibit fast growth and potential for heavier shells and more tissue, but not at every site. We found that if it was a good growing area already, the triploids did not confer that great an advantage over the diploids. And so a grower in that area might test and try triploids, but if he didn't want to spend the extra money, chances were his outcome would be quite acceptable. And then after that study, we sent out a survey. So this was another way to also gauge or get feedback from their collaboration in the experiments and to help guide further work. So We had wanted to know their overall satisfaction with the performance of the triploid oysters, and we found that almost 70% were satisfied. So that was good feedback. And then we asked them to rate their satisfaction with triploids in a lot of different areas. And it was interesting to find out where they were either dissatisfied or very dissatisfied was in seed availability or the cost of the seed. At that time of that experiment, the cost of the seed also included what do you call it? There were royalty charges that were added to that. So the seed was pretty expensive, and that was their biggest complaint. Other than that, they were pretty happy. And another recent study that is Ketchum still here? Hi. The test of floating oyster grow type cages versus bottom cages. Growers were just starting to use these back in 2010, 2011, and they wanted some guidance before they started investing in gear. And so we provided that through a comparison study, floating versus bottom. Found out that there was a significant difference in mean percent survival, with the survival being better in the floating cages. And then moving on, just from just a visual on that, the bottom versus the floating, it was pretty dramatic, even qualitatively. And moving to the current state of aquaculture, at least in Massachusetts, in many areas, it's 95% oysters. And knowing that what goes up often comes down, we're trying to look ahead a little bit and start working with alternative species as not necessarily an alternative crop to oysters, but to maybe augment production if when times get lean or the landscape changes for oysters. And some of our options we looked at: razor clams, blood arcs. Everybody loves a clam with hemoglobin. And bay scallops. So we experiment with growers trying to grow out razor clams. You don't have razor clams down here? You do? Yeah. Very, very active swimmers. Containment is the biggest issue with them. They like to be in the sediment. You'll need to cover them and keep them covered if you want them to remain. One of the sites up in Wellfleet in growing out razor clams was able to utilize a quahog nursery box for his razor clams. So he grew those till they got a little bit bigger and then moved them into raceways, much as he would have with his hard clams. The only thing we found out was, if you see the little shovel, as he's shoveling the sand out to move the little razors, they're all getting crushed. I know. And then again, site differences. Here you have in Wellfleet and Yarmouth, which one is on the north side in Cape Cod Bay, where that tide goes way out. The other one is in a subtidal site. And again, these are the same cohort of seed and the vast difference. And again, more reason to do this in a lot of different areas. The next species we're working with is the surf clam, which is the ashtray clam, those giant, usually offshore fishery, but raising them hopefully within 1 year to be called butter clams and another alternative species. We have a lot of sites, subtidal and intertidal sites, research farms that we're working on these. Different gear, Florida bags. Florida bags do not work in our region. We tried under netting, we tried within cages as well. And our best results for this new alternative species are either under nets or in bags, pinned to the bottom and allowed to sand in. Those seem to generate the best results. And we also, at one of the sites, we got a marketable size product within 1 year. So that was we were really keen on that. Same issues you deal with, whether it's predatory snails or other predators. Let's farms. And one final thing, as a sort of an outgrowth to the Research Farm Network, is the shellfish disease monitoring that we do. And we're calling this the Disease Research Network. And we have stations throughout the Cape Cod region and southeastern Mass where we work with growers in each area and collect oysters and routinely send these off for disease analysis every year. And now we can start to put together a picture of the dynamics of disease and more information for the growers to know what's coming down the pike for them. So if they know that they have one or more diseases in their animals, they might be more tempted to sell them as opposed to overwintering them, or instead of waiting for that perfect oyster to reach a perfect size. And in addition to the Disease Research Network, we also collaborated on a multi-state research farm project, and this was called NARFnet, and that would involve from Maine down to I think we had even New York involved in that, where we tested gear. Again, the same gear went out to all of the sites, and looking at the flip bags to see how they performed from site to site. Thank you. No, we collect all the data. They are, if there's gross fouling that's occurring, like a big algal mat comes over it or something becomes dislodged, they'll pin it back down for us or call us, but no, they're not collecting data.